Assalamualaikum warahmatullahi wabarakatuh, and very good morning. My name is LUTHFIL bin Muhammad AZMI.
My name is Ahmad Bukhari bin SHAHRIZAN.
And today we will be presenting about our microprocessor mini project, which is the dynamic fan controller.
Our lecturer in charge is Dr. Siti Hazurah, binti Indera Putera.
So I will be doing the demonstration of this project. Okay, let's see. So first we are using the temperature sensor, which is over here, the buzzer, the DIP switch and the LED. Okay, first I will be showing about the manual controller for the fan. So here we are using 3 switches and 3 LEDs. So I will be showing you the first speed, which is the low speed on the first switch. Here, this indicates it's on low speed. And the second switch indicates it's on medium speed, and the last switch, which is the third switch, indicates it's on high speed.
Now I will explain to you and demonstrate the temperature system. So this is our temperature sensor. If the threshold is exceeded, it will produce sound. The buzzer will produce sound. The objectives of this project are: first, to design and implement a dynamic fan controller using the HCS12 DRAGONBOARD that the fan speed can be manually adjusted based on the surrounding temperature conditions. Second, is to provide visual and audible feedback by using LED indicators and a buzzer for enhanced user interaction and safety.
So I will be explaining about the flowchart of the system. So at the start, the temperature sensor will detect the environment of the surrounding temperature with a decision, which is it will detect hot or cold. So it will go through the HCS12 DRAGONBOARD, which determines the amount of temperature that will be detected. If the temperature is hot, the HCS12 DRAGONBOARD will give information to the buzzer, which it will turn on. The buzzer turns on, and then it will be looped back to the start. Unless if it's cold, the HCS12 DRAGONBOARD will be looped back to the temperature sensor until it will detect a different temperature reading. So here we also have another branch, which is the DIP switch as a fan speed controller. So as you can see, the DIP switch acts as the level of the fan speed controller, which also, if you turns on the first switch, it means that it's on low speed. If it's on low speed, the LED will indicate that the fan controller is on low speed, which is only the first LED lights up. And then if we turn on to medium speed, which is on the second switch, only the second LED lights up. Means that the fan speed controller is on medium speed. And lastly, if we want to turn to the high speed, which is on the third switch, only the third LED lights up, which visualize that the fan is on high speed. And all of this will be looped back to the DIP switch. So yeah, thank you.
So this is our coding that we use in our project. The origin value is $2000, and we load S to initialize the stack pointer to $2000. This part is to define the input and the ports of the board. DDRB is to set port B as output for LED control. DDRH is to set port H as input for the IP switch. DDRJ as output for temperature control. And PTJ is to enable temperature sensor. And lastly, DDRT as an output for the buzzer control. For temperature sensor, We use the ATD0CTL2 because it is the variable to change the analog to digital, from analog input to digital output. H1 is to begin the temperature sensor system. BHI again is for when the temperature exceeded the threshold. It will branch to again, and this section is the coding to produce, is for the buzzer to produce sound. And for BLS H1, if the temperature is not exceeding the threshold, it will branch again to H1, and the process will continuously repeat. For the buzzer, the frequency of the sound that produced 500 Hz. Beside PTT is to turn on the buzzer, and JSR is to call the subroutine, jump subroutine. And BNE tone is for to ensure continuously repetition of the sound. So if the temperature is exceeding the threshold, the buzzer will produce sound continuously. And if it does not exceeding the threshold, it will branch to H1, and it will repeat the sensor to continuously detecting input.
Okay, so the conclusion of this project, the dynamic fan controller project successfully demonstrates the application of a microprocessor system for temperature-based control. The HCS12 DRAGONBOARD was effectively used to develop a system capable of detecting overheating and providing manual adjustments for fan speed through the IP switches. Visual indicators via LEDs and auditory feedback through a buzzer enhance user interaction and safety of users. Although the system operates efficiently, future enhancements could improve its functionality, such as by using an automatic system, fan speed adjustments based on temperature, and integrating advanced features such as LCD displays and wireless connectivity, which is IoT. These upgrades will extend the system's practicality and usability across various industries, ensuring safer and more efficient operations. And that's all. Thank you.